U.S. Army to begin M1E3 Abrams prototype operational testing in summer 2026. The M1E3 prototype, unveiled earlier this year in Detroit, marks a break from incremental Abrams upgrades, introducing a lighter, more modular design tailored for contested environments. Army officials aim to validate performance with operational units before deciding on production around 2027, contingent on meeting survivability, mobility, and sustainment benchmarks. Early design priorities include reduced logistical burden, improved power management, and enhanced integration with networked battlefield systems. This new phase follows a strategic decision taken in 2023 to abandon the M1A2 System Enhancement Package version 4, SEPv4, upgrade path in favor of a more transformative redesign. General Dynamics Land Systems, the prime contractor for the Abrams family, leads the engineering effort alongside a consortium of industrial partners. Caterpillar provides the propulsion system, while SAPA supplies the transmission. At the same time, Endural Industries and Applied Intuition contribute to autonomy-related functions, and Roush supports integration work on early prototypes. The Army has already received an initial vehicle, with additional units expected throughout 2026 to form a platoon-level test element. The testing campaign will be conducted under the framework of the Army's Transforming in Contact initiative, which places emerging systems directly into operational formations to refine both equipment and doctrine. This approach shortens feedback loops between developers and end users, allowing design adjustments to be informed by real-world conditions rather than extended laboratory cycles. According to Ingram, the pace of transition toward production will depend on how these early prototypes perform in terms of reliability, survivability, and operational effectiveness. The M1E3 diverges in several key areas from earlier Abrams variants. Its propulsion architecture replaces the traditional gas turbine with a hybrid configuration centered on a modified Caterpillar C13D six-cylinder diesel engine coupled to and a CT1075 loop transmission. This combination is expected to reduce fuel consumption by up to 40 to 50% compared to the M1A2 SPv3, while also simplifying logistics by eliminating the need for specialized turbine maintenance. Reduced fuel demand directly translates into extended operational endurance and a smaller logistical footprint, which remains a critical constraint in large-scale, mechanized warfare. Mobility and weight reduction form another axis of the redesign. The Army aims to bring the M1E3's mass down to approximately 60 tons, a marked decrease from the 78-ton M1A2 SEPv3. This is achieved in part through the adoption of lightweight tracks developed by American Rainmetal and a hydropneumatic suspension system likely derived from Horseman Group technologies. Such suspension allows adjustable ride height and improved terrain adaptability, enabling the vehicle to modify its profile for concealment or stability during firing. Lower weight also enhances strategic deployability, particularly for rapid transatlantic or Indo-Pacific movements. Crew architecture undergoes a more radical shift. The M1E3 introduces an uncrewed turret, relocating a three-person crew into a protected compartment within the hull. The traditional loader position is removed, replaced by an autoloader system feeding the 120mm smoothbore main gun. This configuration reduces crew exposure and internal volume requirements, while potentially increasing rate of fire consistency. It also aligns with broader trends toward remote and automated combat functions seen in other next-generation armored systems. Sensor integration reflects the same evolution. The Leonardo DRS Stabilized Sight System, S3, combines electro-optical and infrared imaging to provide target acquisition under varied conditions, with detection ranges extending several kilometers depending on environmental factors. In parallel, a distributed camera network offers a 360-degree situational awareness capability, allowing the crew to operate with closed hatches while maintaining full visibility of the battlefield. These feeds can be integrated into helmet-mounted displays, supporting augmented overlays of tactical data. The vehicle's survivability suite incorporates the Iron Fist Active Protection System, designated XM251 Active Protection System, APS, developed by Elbit Systems. This system detects and intercepts incoming threats such as anti-tank guided missiles and rocket-propelled grenades, and recent disclosures indicate a capacity to counter certain classes of loitering munitions. Complementing this active layer, additional passive armor solutions tailored against drone threats are under evaluation. The combination of active and passive defenses reflects the increasing density of precision-guided threats on modern battlefields. The M1E3 is designed to support more agile armored formations capable of rapid deployment and sustained maneuver. Reduced fuel consumption extends operational reach, while lighter weight facilitates transport across infrastructure-limited regions. The integration of advanced sensors and networked communications enhances target acquisition and coordination within combined arms formations. If coupled with autonomy-enabled functions under development, the system may also reduce cognitive load on crews and improve reaction times in high-tempo engagements. Beyond its technical attributes, the M1E3 program signals a recalibration of U.S. armored doctrine in response to both peer competition and lessons observed in recent conflicts. The emphasis on reduced logistics, improved survivability against drones, and faster fielding cycles reflects a recognition that future engagements will place equal pressure on sustainment and adaptability as on raw firepower. Moreover, the accelerated timeline suggests a willingness to accept iterative development rather than waiting for fully mature designs. The introduction of a new Abrams variant is likely to influence allied procurement strategies and competitive dynamics among major armored vehicle producers. European programs such as the Main Ground Combat System, MGCS, and South Korea's K-2 developments will be measured against the M1E3's performance and export potential. At the same time, adversaries may adjust their anti-armor doctrines to account for enhanced protection systems and reduced logistical vulnerabilities. The result is a gradual shift in the balance between protection, mobility, and networked warfare, with implications extending well beyond the U.S. Army's own force structure.